The first task of this course is simple. Move the object A to the given position B on clicking the Teleport button. The first question you might ask is, how do we describe the position we want to Unity? Let's create a simple cube and take a look at its transform component. Position of the object is stored in the position property of the transform. By combining x, y, and z, we create a structure that is called vector. Currently, all vector values are equal to 0, meaning that the object is at the origin of the coordinate system. Let's take a look at a 2D dimensional vector. Such vector has a start point and the end point. The points are connected with an arrow that points toward the end point, showing the vector direction. The distance between the start and the end points is called the magnitude. For the cube we have created, the starting point is at the origin of the coordinate system, and the position vector has 3 dimensions. The coordinate system is represented by the colorful axis that appears when you select the cube with the Select tool. The endpoint will show the current object position. If you move your cube to the right, you will increase the x value. Moving the cube up increases the y value. And by moving the cube away from the camera, you increase the z value. I must mention that the transform component shows not the global position of the object, but the position relative to the object parent. We'll discuss this in the future lectures. For now, since our object don't have parents and exist at the top of the scene hierarchy, this relative position is equal to the global position. In Unity, vectors are represented by structs vector2, vector3, and vector4. The last one is the 4-dimensional vector, which we'll not cover in this course. Vector2 is usually used in 2D games, and it stores just x and y. Vector3, as you might already guessed, stores the z value as well. However, you can pass a vector2 to the transform position, and Unity will figure out that it should use z equal to 0. Most of the times, vector2 and vector3 objects are interchangeable. Okay, so now let's create a 2D object and modify its transform position vector with our code. Create a custom C# script and attach it to the object A. To modify the object position, you create a new vector3 with some coordinates and pass it to the object transform position. For now, let's do that in the start method. Nice, our object moves on start. You can modify the x, y, and z coordinates so the object moves closer to our target, but I'll show you a more handy way. As you can see, the target is a separate game object. That gives us the opportunity to take the vector3 value from the component position property and pass it to our object. Of course, your object needs to know about the target. So for now, let's firstly pass the target to our custom script using the serialize field attribute. It will make our field visible in the inspector as if it was public. Now drag the target to the field that appeared in the inspector. Nice, so how would you pass one transform position to another? If you want to write the code yourself, please stop the video now. Otherwise, I'll show you the solution in 3, 2, 1. Voila! Pretty easy, right? Now let's move to the button script. For the sake of simplicity, I'll create a button without using Unity UI system. I'll create a game object and add the following components: sprite renderer, which will display the button image, box collider 2D that will define the clickable area, Finally, the custom script for moving the object. I'll call it moveOnClick. Inside the moveOnClick, we store two transforms, the object A transform and the target B transform. Set the serialize field attribute for the field and drag the object and the target to the script in the inspector. Now let's handle a mouse click. Unity has an appropriate method called onMouseDown. Inside the method, we'll put the code that copies the target transform position into the object transform position. Remove the custom script from your object since you no longer need to move the object during the start phase. Finally, try the button out. Nice!